at some point. I also don't know if anyone's online, actually. Doesn't look like it. What's that? Krishana? She's a junior this year. Yeah. So I'm not recording. I'm not sharing my screen either. I guess I got to share my screen for that recording video to do much of anything, right? But what we're going to work on today is making some gear sets in SolidWorks, mostly to show you guys how to use the equations in SolidWorks across multiple parts. And that's really going to be our goal, is to say, here, look, I can define a set of values that I want to drive something in my design, and I can have that set of values apply to, however many parts that you want by incorporating the same document as the driver for all of those values. Okay, so that's kind of the goal for us in class today. If you haven't already, go ahead and open up SolidWorks. And we're going to go through this step by step with the kind of easiest basis for where you might want to do something like this. And we'll get a little bit more complex as we go through the process. Does that make sense, everybody? We're a pretty small group. So, discussion and talking about where you might want to use this stuff. Hey, I got stuck on this part. I don't understand why you did that this way. Or I got an error that looks like this. We should have plenty of time to discuss that within the hour. If it hits 9:20 and I'm still yammering away and like totally oblivious to the fact that we run out of class time, someone let me know. I think there is a class in here at 9:30. Like, you guys, seniors have a class at 9:30? Transport, but it's not here. It's okay. Yeah, so I don't want to make you late for transport. So just let me know if we're getting close to that time. Anyone still waiting for SolidWorks to load? Issa is. You got to go in through apps anywhere. So hopefully that won't be too much of an issue. It will probably ask you to accept the license agreement. That's just We're going to start off pretty simply. I'm going to start off with a part. And on this part, I'm going to basically make a drawing of what I want my gear assembly to look like on the face of a plate, which I will then later attach the gears to. So I'm going to start by making a part. And I'm going to use IPS for my unit system. If you guys already have a different default unit system, you can remember that you can change the unit system in SolidWorks using the menu on the bottom right-hand corner of the screen. I'll show you that after my SolidWorks finishes loading the part. Probably loading all my default settings. I haven't run SolidWorks on this computer yet this semester. So you can see down here, I have IPS. That's my default unit system. If I click on that, once it loads again, I feel like I'm having more computer troubles this semester than I've ever had. I don't know if it's just because like the computers are getting older inside the classrooms or what, but there we go. There's a mandatory update available for the 3D Experience Marketplace. I don't care about that right now. So again, there's my unit system. I'm in IPS. If you're in something else, just change it to IPS. I'm actually not going to start by drawing anything. I'm actually going to start by defining the parameters that I want to use to drive my whole assembly. So I'm going to go into Tools. Hey, Krishana. Go ahead and get on a computer and get SolidWorks going as soon as you can. And then come down to Equations, which is way at the bottom. Hopefully this is something you guys have all seen before. But again, I'm going to a new part, going to Tools and Equations. And this is where I'm going to define all the equations I want to use for this activity. And I'm going to define a couple different things here. I'm going to start off with spacing. And I'm going to make that 2 inches to start with. You can use something else if you like. The whole idea with this is that we can make whatever we want. A gear ratio. And if you wanted to call that like R or just GR or something, again, the names here are not really that important. I'm going to start off with 2. spur gears, which is what we're making, are reasonably good at a range of gear ratios that are not extreme, right? So 2-to-1, 3-to-1, 4-to-1, 5-to-1, or something that's closer to 0.5, the inverse of all those, all work pretty well. You can't make the smallest gear too small. You need to have about 12 teeth to get an efficient profile. So a lot of times that ends up being a limiting factor. Once you start to getting to 100-to-1 or something like that, you either need multiple gears or you need to move to something like a worm gear or a different type of gear set, right? So the gear ratio here should be kind of some reasonable number, right? Not huge, not tiny. Closer to 1 being typically more efficient. I'm going to specify the pitch, which is the spacing between the gears. This should be something that's somewhat comparable, right, to what we want the size of the gears to be. But we're going to make it 0.1 just to start off with. And then I'm actually going to have 2 different sizes for the actual gears themselves. I'm going to have an input gear and an output gear. I'm going to diameter for each of those. So I'm going to say the diameter of the input gear. And this I'm actually going to make a function. So this is going to be a function of the spacing, because what I want to do is if I want to have 2 gears that have some spacing between the 2 of them, and I want a certain gear ratio, that's going to dictate how big each of these gears can be, right? And there's an equation for this. So I'm going to use 2 times, and then the spacing is the total distance between the gears. So it's going to be the spacing. And I actually need to put this in the quotes to get the actual correct nomenclature there. So if you see quote, spacing, quote, that'll work correctly. If I use just spacing, it'll replace the spacing with the value, but it won't update automatically if I change spacing. So whenever you're using global variables, you almost always want to say quote, whatever the name of the global variables is, quote, and then it'll work appropriately. And then I got to divide that spacing by whatever the ratio of this is going to be as a function of gear ratio. So for my input gear, I'm going to use 1 plus gear ratio. I don't know why I keep wanting to put n on that. And close parentheses. And then for my diameter output, I'm going to call that di out. It's going to be pretty much the same equation, except for it's going to be 2 times the spacing divided by 1 plus the inverse of the gear, 1 plus 1 over the gear ratio. And if you guys want to, prove to yourself how you got that, if I take diameter in plus diameter out, divide both those by 2 to get the radius in, the radius out, the sum of the radii has to be equal to the spacing, and the ratio of the diameter in to diameter out has to be equal to the gear ratio. So those 2 equations come from basically solving the simultaneous equations for diameter in, diameter out as a function of gear ratio and spacing, right? So, and you can see here that the diameter out actually is twice that of the diameter in, which is what we want. It'll give us a 2-to-1 gear ratio, right? Make sense? I'm not going to go through the actual math of deriving that, but you guys could do that if you wanted to, or you can just trust me that it's right. Okay. Anyone have any difficulty getting those equations plugged in? Maybe with the exception of Krishana. Krishana, you able to get Solidworks going yet? Okay. Krishana, what I would suggest you do after you get loaded, you're probably just going to want to download the zip file that has the Solidworks parts and then open the gear plate to kind of catch up to where we are right now. Does that make sense? All right. So that's all our global variables. And we can use this to define the entire profile of our gear set. So the next thing I'm going to do is I'm actually going to define a sketch that shows what these gears would look like on the front plane. So I'm going to the front plane and I'm going to sketch. Hey, Corey, go ahead and get logged into SolidWorks as soon as you can. I'm going to draw 2 circles. One at my origin and one just off to the right of that. I'm going to have a center line that connects the center of those 2 circles. And then I'm gonna draw two more circles, one a little bit bigger going towards the center line, connect to the origin, and then one a little bit bigger going to the center line like that. And that's gonna be basically a representation of my two gears. Does that make sense to everybody? So the first circle here is on the origin. I can just do the whole thing again. So again, I'm sketching on the front plane. I'm going to draw a circle centered on the origin, another circle that's just kind of off to the right of that. I'm going to change this to a center line. I'm going to draw a center line from the origin to the center of the second circle. Go back to my circle tool, and I don't have to do this necessarily in this order, but it's a little bit easier to see it if I've got the center line there. And then again, starting from the origin and then just making that attached to that line. And again, starting from the center of my second circle and making that attached to my line. So that's kind of like the Aztecian smooth, perfect gears that Tony was talking about in his video. And then I'm going to drive almost all the dimensions of this sketch via a set of global variables. So let's do that. So I'm going to start by putting in some dimensions. This line here, the length of this center line, that's the spacing between the gears. So I'm just going to say equals global variables spacing, enter. I'm going to say this is my input gear and this is my output gear. So I'm going to specify the diameter of this one. So that equals to global variables diameter in. And I'll go to this other one, click it out. Yeah, I guess I'll leave it. Make this driving. Okay. I'm actually going to take this tangent relation off. And the reason I'm doing this is I've already set up the global variables. Oh, I accidentally did the wrong one. To make this the correct diameter. And my goal was to show you all that these kind of fit. Really, if I wanted to, I guess I could have specified just the diameter in and then let Solidworks calculate the diameter of the output. But I'm going to use that in other places as well. Yeah?
Why does the tangent make it overdefined?
Because with the spacing that we have and the diameter of my input as it is, that specifies how big that other gear has to be, right? Because the sum of the radii has to equal the spacing if they're touching each other. But I've done that with math rather than the constraint, so I can't do it both ways. It still works out to be the same values, right? Like nothing changed when I did that. But this one is actually driven by my global relations as opposed to the sketch relations. Yeah, Isa.
What's the diameter on the
This one here, this is my diameter in. So you should be saying equals to, quote, diameter in. And then the one on the right is my diameter out. And then for the center one, I'm just going to use a 0.25 inch diameter because I don't really care what the size of this input hole is. I could have specified that in my global variables as well. I was just trying to keep this simplicity here reasonable.
The 0.25, where is the diameter in or diameter?
The 0.25 is just 0.25.
Oh, okay.
So only the ones that have the little epsilon are equations, right? And my gear ratio is really just being used to calculate my diameter in, diameter out. I'm not putting that onto this. And I haven't used pitch yet because I haven't added any teeth, right? But I'm going to use that here in, I don't know, maybe 15, 20 minutes. That makes sense to everybody? So I say equals to, and then it should give you the option to, I'm going to plug it in. Oh, you have to define the global variables first. We did that before. Okay. Yeah. So you probably want to plug in your computer, and you can download these files before we move on to the next part. All right. So I'm going to leave this sketch just like that. And from a design standpoint, I'm not generally going to be making gears. I'm going to buy gears off the shelf. If you're making gears, you're either a hobbyist with a bunch of time on your hands, right? And you have like a really specific application and you want to make a YouTube video on how to make a gear. Or you're a gear manufacturer and this lecture is way too simple for you, right? most of the time when you're looking at gears, you're just picking gears. And this model like here is simple enough to show me what the gears are going to look like with a given spacing and a relative size. So from a design standpoint, that might be all you ever actually want to do when it comes to gears. Is look, I have a sketch that shows me how big these things are going to be. I could throw this sketch as a part into an assembly just to see how everything would fit together and look for interferences and stuff like that. I don't need to do the extra work, is basically all I'm saying. All the stuff we're doing after this, it's more just like, hey, let's look how these things work to understand how all these things interact, right? But it's kind of a fun example. The next thing I want to do is I'm actually going to make this into my base plate so I can attach gears to it. So I'm going to make a new sketch on the front plane. And I am going to offset from these two circles. I'm going to do them one at a time. I'll use 0.25 as the offset. So offset entities. Same thing on the other circle. I'm going to trim out the centers of these. And then I'm also going to make a line that goes tangent across the top. Actually didn't get the tangent relation there, but I'll add it in after in a second. And the bottom, that one I did get the tangent relation. So if you don't get the tangent relation, don't sweat it. Just use Control to select the arc and the line. Click on the tangent relation, and it'll add it in. Again, tangent. And then I'm going to trim off these extra little ones using the power trim tool. And then I'm going to convert my center circles here. So I have a single closed contour. I can do the whole thing all over again. Actually, I would suggest you guys like just watch me do it the first time, and then the second time try and follow along.
Yeah.
All right. So we're just going to start all over. We'll see it backwards. So again, this is my previous sketch. I've exited that one. So I have a new sketch on the front plane, same plane as my first one, right? First thing I'm going to do is I'm going to do offset entities. So I'm clicking the offset entities tool. I've specified the size already, so I'm doing a quarter-inch offset. Click on the first circle, click OK. Click on offset entities, click on the second circle, click OK. Go to the trim entities tool, make sure power trim is selected. That should be the default. Trim out this center piece. You actually don't have to do this now. You could do that after drawing the lines, but I don't like my sketches to get too complicated. Click on the line tool. Make sure you're coincident with one of the edges here. Come across. If you're smart, you can try and look for the tooltip. There's the tangent right there. And that gave me the tangent without having to add it in afterwards. If you don't want to try and find the exact right position to get the tangent relation, don't worry about it. Oh, I hit escape. I'm not allowed to hit escape. You can always go in and edit the relations. If you get one you don't want, click on the relation, click delete. If you don't get one you do want, click on the things you want to add the relations to, typically just 2 at a time, and then click on the relation you want to add. Unless you're trying to add like a horizontal or a vertical, then you only need to click on the one. Click on the one. Reminder to save your work, yeah. Use the power trim tool again to trim off those extra little bits. And then I'm going to use the convert entities tool to convert my center holes. So I'm just clicking on the 2 center holes. And then accept. And then what I'm going to do is I'm going to extrude that. And I'm just going to make it a 1/4 inch thick. I'm going to have to go the other way because I want my sketch to be on top of that so I can still see it. And again, I'll do that one more time in case you were watching. Watch first, follow along second, right? So again, click on sketch, go extrude. If you haven't already accepted your sketch, if you click on extrude, it'll automatically assume that's what you want to use and you don't have to select it. So I'm just going to extrude that backwards 0.25 inches and I'm going to accept it. Right?
So the convert entities that you did for the 2 center holes,
Yeah.
makes it move to just cut those out.
So
Shoot it.
whenever you have one closed contour, right? If I have circles inside of circles, it assumes that that circle is going to be a hole.
So why do we convert entities in the middle?
Well, so I need to convert the background sketch in my first sketch onto my current sketch so I could use that to do the extrude. Otherwise, it won't use those holes, right? And I'm only doing this so that way I have the sketch kind of showing on top of my part, right? If I wanted to, I don't really need those background circles. It's more for visual than anything else. 0.25 inches. All right, especially for Krishana and Tori. But I do have all the files that we'll be using for this lecture up on Canvas. So I would suggest you go into our lesson 1 page. Let me close this document. You download the solidworks.zip. And you probably want to get this gearplate.sldprt. For everybody else who's been following along, go ahead and let's save this to a folder on our desktop. Now, because SolidWorks, like MATLAB, right, will pull files with the appropriate names from the directory. So if you have an assembly and there's a file with a specific name in it, and it's trying to pull that file for a drawing or for an assembly, it's a really good idea to put all your parts into a specific folder for just that product. So I'm going to make a folder on my desktop called L01 gears, lesson 1 gears. And then I'm going to save this as gear plate. So I'm going to do file, save as, change my directory to that desktop folder, L01 gears. I'm going to call this gear plate. Again, just like Sam mentioned, important to save your work on a regular basis. So were you able to get that file?
Getting it now, it's your plate, right?
Yep. Shauna, were you able to get the file? Yeah. Okay. So in that gear plate file and inside my file here, I have my global variables already defined. I don't want to have to redefine those global variables in my next part. And I want to be able to change one thing and have it update for all of my files. Does that make sense? So what I'm going to do is I'm going to export my global variables to a text file. And then I'm going to import that file to my gears. And I'm going to link the file to the variables inside all of my parts. So that way, if I change it on one, it will automatically change in all of my files, which is what I want to be able to do with this whole topic of this lecture. So let's go back into our equations. These are the variables I want to export. I don't really want to export the ones that are specifically for this part. Kind of an important catch there is that I want to keep this a little bit clean, right? But I'm going to start by exporting the spacing, the gear ratio, the pitch, the die in, the die out. Those are the only things I really want to export. So I'm going to go to export. I do want this to be in the same folder as my part. I don't want to call this generic, so I'm going to call it equations. I'm going to call it gear equations. Using the default name like part 1, assembly 1 is generally a bad idea. And then I'll click save. And then you'll notice here on this export options, I have the option to export and link my D1s, sketch ones. Uncheck those ones. Right? So these are the ones that are being exported. These are the ones that are being linked to the file for this part. So I only want to use those global variable bits, not the dimensions that are being driven inside my part. And go ahead and hit export. Everybody see that? Actually, I'll hit cancel, then I'll go through that whole process one more time. So again, hit export, go to your appropriate directory, change this to gear equations, hit save, uncheck everything except the global variables. So uncheck your D1, D2, D3s. Make sure the link to file is checked, and then click export. Now you'll note here that my values have gone gray. That means that I can't edit them right here, but they're linked to the file. I can edit them in the file. So I'll click OK. If I go into my file, so I'm going to go to my desktop, L01 gears. Here's my equations.txt. That's what it looks like. If I change my gear ratio here to 3, maybe the spacing to 2.5, and then I save, and then I rebuild on the part, you notice it automatically updated my dimensions. Pretty cool, right? Now, this functionality would be kind of limited to exporting to the part, except for the fact that now I can use this file in other parts. So if you had like, you know, a V8 engine, right, where there's hundreds of parts that are all basically driven by the same parameters, this can be really helpful from a design standpoint because you don't have to open and edit 100 parts to make a change in the design, right? And as long as you're careful about how you build the parts, that can be fairly robust. You can't have a lot of errors with that. If you're all of a sudden now my gears are like exploding out of the case of the design or something. Yeah.
Is there like an Excel functionality for that too?
There is, but it's a different tool set and it works differently. If we have time, we'll get to that today. If not, we'll talk about that on next week.
Like a text file.
Yeah, the text file. The thing about the text file is it's very easy to kind of read out, right? You can use design tables, which is a different tool, and that's really more for generating different configurations of parts, right? And that doesn't easily integrate across multiple parts. This one allows us to go across multiple parts more easily. All right. So let's actually make the gears themselves. So I'm going to go into File, New, and then I'm going to click on a part. I'm going to click OK. And if you guys are using the lesson document later to look at this, I do this in a few more steps, but I'm going to skip a few steps just to get us to a little bit further along, a little bit faster. And we're going to make the whole gear, and then we'll put it in the assembly. The document on Canvas actually has you make the assembly with a blank gear and then add the teeth. We're going to add the teeth and make it all at the same time. So let's make a new part. I'm just going to, right off the bat, I'm going to save this as gear in. I'm hearing a lot of blings. Is that? All right, so I've got a gear in part, right? Now I want to load in the same equations I was just using for this part. So I'm going to go back to my equations tools. And you guys have any guess as to what option I'm going to use? Yeah, import. All right, pretty intuitive, I think. Click on my gear equations.txt, click open. Say which ones do you want to import. So just to note that each part can import different values from the text file, which is both a mixed blessing, because one, if I add new ones to the text file, it won't automatically add them to my part, right? You have to re-import them. But also, if I do something weird in one part, it's not going to necessarily break all my other pieces, right? So you can have a text file that had a bunch of different ones that not all of them were showing up in all of your parts. So it's good for some things and not great for others. I do want to make sure the link to file is checked. That's the default. And you see I have now the same global variables in this part as I had in the other part. So let's start by making our gear. So I'm going to click OK. I'm going to go to my front plane and I'm going to sketch. I'm going to draw a circle with a 0.25-inch diameter. That's just for my hub. And then I'm going to draw a construction line. So I'm going to start by drawing a circle. I'm going to change that circle from a line to a construction geometry by right-clicking on the circle itself. And then I'm going to make that construction line have the diameter in. So equals global variables, die in. I'm going to pause there and then redo that because this is going to be the basis for my circle. So I'm just going to undo real quick. So again, just a new sketch on the front plane, drawing my center hub first, clicking on the center point circle tool, clicking on the smart dimension tool, clicking on the circle, placing the dimension, giving it a value of 0.25. Clicking on the center point circle tool again. Actually, pose already was active. I probably didn't have to click it again. Drawing a new circle, right-clicking on that circle to change it from a solid line to a dashed line, the construction geometry, the kind of dash dot line, or whatever you call it. And then I'm going to use that as the diameter of my circle. So I'm going to say equal to global variables, die in. Now, the reason I can't make a solid line as my nominal diameter for my gear is that I need the gear teeth to mesh. So the maximum size of the gear actually has to be a little bit bigger than that. And I want the minimum size of the gear to be a little bit less than that. Does that make sense to everybody? So what I'm going to do now is I'm going to offset 2 lines from this. And then I'm going to use those to draw the actual gear. Okay. So I'm going to offset. And I'm actually going to use a distance of the pitch divided by 2. So I'm going to say equal to, actually, I might have to add this after the fact. Yeah, because it's not giving me, well, let's just try typing it in. Pitch. Sometimes these tools won't let you use equations inside the set. Yeah, okay, never mind. So just type in 0.1 for now, and then we're going to change it after we have the dimension on here. So offset 0.1, click on that, and then click on bidirectional. That's going to give us 2 circles. And then once I have the equations down here, now I should be able to edit these and make them equal to global variable pitch divided by 2. I'm going to do that again in just a second. So if you're not quite following along, just watch us real quick for a second here. Global variables, pitch divided by 2. So that's kind of an important thing to take away just in general for SolidWorks, is that sometimes it won't let you add a global variable in one place, but it will let you add it in a different place. So on here, when I went to go do my offset for this part, it won't let me put an equation here, but I can just put in a value. And again, I'm doing it in both directions. And then once I have the dimension on the part, I can go through and I can add or edit this dimension to make it an equation by doing equals to. So if you ever get in a situation where it's like, hey, it won't let me make a global variable here, what do I do? Try finishing the geometry, showing the dimensions on the part, and then editing it to make an equation. And that works like 90% of the time. There are still a few situations where like it won't let you just have it be a equation at all. But this one's different. Yeah, Sean. When you do tools equations? Oh, so it's there. Yeah, it's tools, and then equations are almost at the bottom. I actually had to scroll down to be able to see it. And that's largely a function of your screen resolution and your display size. How many people are stuck on getting this? Then why don't you just load the file? You already have it. Why don't you just load the file? Yeah, you can do that outside of class time and follow along with the rest of the class.
Yeah, I guess.
You're missing the art on this side of this.
I would just taste this one.
You can learn the concepts we're trying to cover. Yeah, so double click on that, say equals. Yeah. Equals. And then global variables. All right. So I've got maybe half of you. Looks like you may have to edit your sketch again, Jeremy, if you left it.
Oh, it's,
Okay. All right. So now let's go ahead, and it's complaining about some of my equations. It's probably complaining to me because I undid it. And so there was a set of equations and then I redid it. And so now the equations are there twice. If you're not undoing and redoing a bunch or messing with stuff like I do when I redo these, you probably are all gonna be okay on that. I'm not sure what the issue is. I'm just gonna ignore it for now. I'm gonna now draw the 2 lines I need to make the profile of this tooth. So I'm gonna say one line like that. This is actually gonna be the cutout and not the tooth itself. So there's one line there. And then the same line, or almost the same line on the bottom side of that. And then I also want to have a center line going from my origin all the way across. That's horizontal. So I'm going to use that to make these 2 symmetric. And then I'm going to exit the line tool. And I'm going to use the symmetric relation by clicking on one dot one point on the bottom of my line, holding control, clicking on the center line, still holding control, click on the bottom dot, and I'll make that symmetric. And then I'm gonna do the same thing for the other side of the line. So I'm click on the top dot, hold control, click on the center line, click on the bottom dot, click on symmetric. Now those two lines are symmetric. I'm gonna set the angle of the gear. So I'm gonna click on Smart Dimension, click on my top line, click on my bottom line, place the dimension. I'm gonna set that to 60 degrees. And now I wanna actually look at the distance, the length of this arc, and I need to make that half of the pitch or a little bit bigger than half of the pitch, depending on how I'm designing this gear and how much clearance I want. So what I'm gonna do is I'm actually going to just make a line or a point at the intersection or the midpoint for that guy, and then the same thing at the bottom. And now I can do a smart dimension from those 2 points to specify the height of that. And I'm going to say that is equal to, again, pitch divided by 2. So global functions pitch divided by 2. That didn't work. I think this is actually supposed to be pitch divided by 4. I did it as a diameter in the previous one. Yeah. So make both of these pitch divided by 4. So my 2 equations down here for the offsets, and then that should look much better. Everybody see that? So I just double clicked on that to edit it, and then change my divided by 2 to divided by 4. And then my
Your point to point's pitch divided by 2, but then you change.
yeah. So the offset is pitch divided by 4, and then the point to point along the midpoint of the actual cut for the tooth is pitch divided by 2. And then the last thing I'm going to do on here is I'm going to trim off the excess parts around there. And I think I actually did this on the wrong sketch. Indeed, I did. Well, we can fix it still. I'm going to exit the trim tool and just clean this up a little bit. So I'm just going to move my offset dimensions a little closer towards the sketch here. Move my 0.5 a little closer so I can see that. You should have something that looks like this. This is what we want. I realized after the fact that I didn't actually draw the main circle first that I was going to cut this out of, but that's okay. I can go back and I can make it right now. So I'm actually going to accept this. I'm going to roll back, and then I'm going to do another sketch on the front plane. And I'm just going to draw the blank for my gear first. So this is going to be 0.25. And this one here is going to be pitch plus, or sorry, diameter in divided by, or sorry, yeah, no, plus pitch divided by 2. Diameter in plus pitch, nope, plus pitch divided by 2. No, because this is diametric instead of radial. The one we had before was a radial because it was an offset. Yeah. And really, I should have done this first, and I could have just converted that outside edge, but I lost track of my order. So I'm going to extrude this as 0.25. And then I'm going to roll forward to get my sketch here. And then I'm going to actually edit this to make sure it looks right. I don't need this center, so I'm going to convert that to construction geometry. And then I'm going to cut extrude this. So features, extrude cut. Then I'll flip it and I'll make it through all. So on my sketch, I had, this one was a solid geometry. I changed that to construction because I didn't need to cut the circle again. Is that what you're asking?
No, so the boss extruded the rollback you just did.
Yeah.
What did you extrude that out?
Oh, 0.25 inches. Yeah. I'm just using 0.25 for basically all of my dimensions that aren't part of my global variables. Yeah, Sam.
I'm caught up with that second sketch and everything, but I missed the dimensions and where they go after the 60 degrees.
Okay. Let's take a look at, so on this sketch, I have my two offsets, and really I probably don't need this outer one. Probably what I should do with this one is just make this arc co-radial with that arc. It's one less set of dimensions I have, equations I have in my part, right? And then this one here is, I don't know why it's showing offset in that direction. This is the distance between the center line and this arc, which is 1/4 of the pitch. This is the distance between the contacting, or the kind of the middle point, the nominal size of my gear, and the tooth. That's half of the pitch. And then this angle here is 60 degrees. I also have these symmetric relations to keep the tooth symmetric about that horizontal line. Now, horizontal line goes through the origin. If you guys' tooth profile doesn't exactly match mine, again, it's not a big deal. You'll still get the majority of the content out here. Yeah. Is your offset after the pitch or? So make sure you do equals whole variables. Make sure you're doing them equal. If you don't do equals, you have to save it, so just erase it. Yeah. And then the pitch there is half, right? Yes, you should do that. Yeah. So equals. So whenever you're using those equations, make sure you're using equals and then the quotes around the global variables. And you should see the epsilon in front of these equations. If you don't see the epsilon, then it's not actually an equation and it's not going to work the way we want it to. Sound good? All right. We have another thing we need to do here. So we need to cut this out and we need to pattern it. So I'm going to accept that. It's complaining that I have equations that are messed up. I'm going to try and fix that real quick. Tools. I didn't do these multiple times when I made it. And I probably should have just done that. Can I just delete this? There we go. It's because I deleted the dimension, but the equation is still there. So I didn't know where to assign the dimension to. At least I think that's what it was complaining about. So now I need to pattern this. But to pattern it, I need to get a number of features, right? So how can I get the number of teeth I need in my gear? Let me see. I'm gonna do a circular pattern, but how do I know the number of teeth that I need for the circular pattern, right? So yeah, I'm gonna use the cut extrude. I'm gonna circular pattern it about the center of my sprocket. I want equal spacing, but how do I know the number that I want here?
Based on the gear ratio.
It's going to be based off the diameter and the pitch, right? So I'm going to use the global variables, the diameter, not just the diameter though, right? Diameter times what to get circumference? Times pi divided by my pitch. Pi might need to be lowercase. There you go. So again, I made that an equation and I calculated the number of teeth I would need given my current diameter and my pitch. Now, the thing that's not great about that is that my diameter times pi divided by pitch might not actually be a whole number. So this is going to round. If I wanted to be more conservative, I could add 1 to this. So that way it's always rounding up because I made my cutout half of the pitch size. So if I have more cutouts than I need, I'm always going to have clearance because my tooth is going to be smaller. Or I can leave it like this and just kind of see how it works out. It may just work out in the end. Also, if I can allow for a little bit of play to allow for more spacing, right? Basically move the gears a little bit further apart. I can use that to account for some of the variance. but it depends on what you're doing. Again, if you're designing a gear because you're designing a gear, you're probably getting a lot more complex than this. You're doing involutes and stuff like that. Does that equation make sense to everybody? Diameter times pi divided by pitch. We're patterning the cut extrude, and we're doing it about the center of the part. And now I do the same exact same thing all over again to make the other gear, right? Right? No. No. What do we do to make the other gear? We're going to do File, Save this one. File, Save As, change name, gear out. And then I'm going to go into my equation editor. The only thing I need to change for this part to make the output gear the input gear is make sure all of my diameters in my equations are diameter out instead of diameter in, right? Because I've driven this whole thing from equations. So what I'm going to do is I'm going to make sure automatically rebuild is unchecked because I don't want it to rebuild as I'm editing these. But every time I see die in, I'm going to make it die out. So I'm going to go die in becomes die out. Die in becomes die out. Die in becomes die out. And if you have a slightly different combination of dimensions, as long as you change every instance of die in to die out, you should be good. I'll click OK. There's my new gear. File, save. Again, another example of how using these global variables can allow us to work much more efficiently. I didn't have to remake that part. It was more or less the exact same part with just different set of parameters, right? And really, if you wanted to make a bunch of different parts, all with different parameters, then you might want to use a design table, which is kind of the Excel version of the same thing. But that won't let you work across multiple parts as easily. You can still do it, it just doesn't work quite as well. You like it? Love it? All right. We have our parts. Let's make our assembly. I'm going to do File, New, Assembly. Click OK. We're going to do this really quick because it's almost 9:20, so we're almost out of time. But I just want to show you guys the gear mate and that this works. So I'm going to get the gear plate, click on the green check mark. That's going to put the gear plate right where it is. I'm going to do Insert, Component, Existing Part. I'll do Gear Out. I'm just going to place that right over there. I don't have Gear In because I don't have it open right now, so I'm just going to drag that from my file folder. I'm going to go to my assembly tools. I'm going to mate the centers of my gears with the holes corresponding on my plate, except that one. Same thing on here, except that one. I'll put the two gears that are actually on the front of my plate because I don't want them on the back like that. Okay. Now I'm actually going to pull in my global variables into this document as well. So I'm going to save my assembly. I'm going to save as file, save as, I'm going to call it gear assembly. And then I'm going to go into my equations. So tools, scroll down to equations. I'm going to import my gear equations. Now I've got those equations in my assembly as well. So I can go into my mates. And I can go into mechanical mates, gear. And I'm going to select my gear here and my gear here. And then rather than using these guys here as ratios, I'm going to use equals die in for 1. I gotta use the right case, die, capital I. And then equals die out. That didn't work. I'm just going to accept that for now. I'm going to try using the after effect. Double click on the gear mate, click on the dimension, make that equals to global variables die in. Okay. Make this one equals to global variables die out. Okay. So again, the same thing like we had with the offset. It didn't let us change it in the actual mate, but it let us change it in the pitch. Now, when I rotate this gear, oh, I may have to reverse. I may have to switch those values. Oh yeah, I've got them backwards. All right, let's do gear mate. Can I just edit? Can I reverse those? I don't know if it's going to keep the same values if I reverse them. No, that's reversing the direction. That's not right. Edit. What if I reverse the faces? I'm going to uncheck the reverse. Okay, I'll just change the value so it's the opposite sets. I'm going to double click the gear mate. I'll make this one equal to die out. This one equal to die in. See if that works. Still doesn't seem to quite be rendering properly. Maybe I had it right the first time and just it didn't look right because I had it, the gears weren't lined up. The gears should stay reasonably well meshed. They shouldn't slide through each other like that. For some reason, it's not giving me the right values on here. Maybe I just need to hit rebuild before I did it. I swear this worked in my office like 20 minutes ago. Let me try just hitting rebuild and save. All right, let's go slowly. Still not giving me the right gear ratio. I think it's still using the 1-to-1 gear ratio instead of the ones I typed into the equations. Yeah, it's not actually resolving those. Why not? You know what? Okay. I think what it was is because I had that gear mate using the surfaces. I think it was overriding my equations. Because it was using the size of the faces, and that was taking priority over the actual size. There we go. Now you can see they're actually moving in sync. They're a little bit offset because I didn't line them up before I did that, but you can see the teeth are moving together now. All right, so just as a quick note, the issue there was because I was still using the sizes of the faces that I had taken. I hadn't overwritten them. When I changed the dimension, it was loading the size of the face again when it actually went to resolve the mate rather than loading in the value because I never typed in a value there. So you gotta make sure you have a value there and then the dimension will drive it rather than the dimension being driven. So I had a driven dimension that I was editing which didn't do anything as opposed to a driving dimension which allows it to change the mate. Which I guess why it's showing a yellow there because that, again, generally in SolidWorks if it's white, it's softer as a background, like for relations and things like that. And then yellow means that it's a hard relation. So that works out better. And we're out of time. If you guys got through most of that and you're pretty happy with how things went, go ahead and submit that to the week 1 progress submission. If you didn't, there's always the overview.docx, which has kind of a Word document walkthrough of this activity. You can do that to reinforce your skills. If you're just here to observe, then that's obviously optional, right? Yeah, thanks for coming. You guys have questions? Yes. Yeah, just submit a zip file of your folder, just kind of like I have there. Don't download mine and rename it and submit it, but like, you know, do your own and then submit it. Yeah, sorry. Yeah. Yeah, I'll put it up here on Canvas after it finishes. Yeah. Although honestly, probably doing the walkthrough document, this document, it might be as easy as following along on there. But you can have both.
Okay. Do you think the video will be uploaded by like before midnight? The week before?
Yeah, I'll definitely have it up there before there. I don't know how long it'll take for the Zoom to finish doing whatever it does on the background. But I'll probably have it up by this afternoon. Yeah. You were not signed up for, well, you're doing it for the honors project. Yeah, you should. You just email me maybe.
Email you like the work?
Yeah, the files. Like, because you won't, I don't know if you'll have the ability to submit.
If I'm not for credit?
Yeah,
Okay.
like to assignments.
I'll look and see.
If you can submit it, then go ahead and submit it. If not, then just email it. Yeah.
I don't think I got the final year made to
Work.
finish. Well, I mean, I got it.
It was going, but it was like yours weren't staying alive. Yeah.
So, well, maybe you can change that later.
Sounds good. I'm gonna stop recording.
Are you gonna share those?